Hey, what's going on, guys? CMK here. In this video, we're going to be programming a digital clock on the CMK computer that I've built based on Arduino Nano, 4x4 keys keypad, and this LCD display. And you can follow this tutorial directly in the web browser. So there is a very accurate Arduino emulator at tinkercad.com. So I'll give you a link in the description down below. Okay, we'll start by implementing the main loop, since I already have the entire program being written and I can now see the program listing on my laptop. You can see this, but yeah, probably I will include this into the video as well, just to give you an idea. So we'll go from top to bottom. So I'll start with the main loop, and then we're going to be filling the functions as needed, as required. So digital clock here, and our program, the main loop, would start at address 200 hexadecimal. And remember that you have the stack in this machine at 0x3ff and growing downwards. Let's reset the A and B registers first. So I can say 0x01, which stands for LDY. I will now provide the instructions, and 0x00. And here we want to say LDI 00. So this loads the value of 0, instant value of 0 to the A register, to the accumulator, and then 0x03 to transfer the value of A register to B register. So this helps us to reset these 2 bytes. And this is needed because when we're going to be reading the data from memory and writing it there, B register is used as an offset to the A register. So to make sure we're reading and writing to the proper addresses, we need to make sure that the B register actually gets resetted like every time we're entering this main loop. Then we're calling 3 subroutines. So call subroutine is opcode 23, and the first one is 013C. And here, so this is the subroutine. So here, instead of writing the address, I would be writing the name of subroutine to make sure that it kind of gives more sense. So this is the main loop, by the way. So main loop, okay. Or maybe even better to say like this. So calling the subroutine called, well, I call it update second, but ultimately, yes, update second. Actually, this subroutine updates the entire clock, not only the seconds, but it enters the point where we are actually updating the seconds. So update in seconds, and the next one is 0x01 0x26, which is print clock. So subroutine print clock. Then we're calling the subroutine to delay things. So 0x01 0x00. Subroutine delay. Okay. And finally, want to read the character non-blocking from the keypad to make sure that we can exit during debugging the program and when we're running this as well. Yeah, just to make sure. Still recording? Yes, I do. Okay. So here, oh, I put this up. I need to say, I'm sorry guys, this is 07 read character. So read character non-blocking. And finally, I want to loop back to the main loop. So load program counter to the main loop. This is how it works. So from here, we're jumping back, and this is actually the loop allowing us to make sure that everything is going to be working nicely. So let's now put this into the memory of the computer. Okay, so I'm going to command mode, the star here. Make sure that assembly mode is also available to make sure that you see the opcodes there. Also, pressing 0 to, yeah, that's actually reset, so to make sure that I'm doing this absolutely from scratch. Like this, go into assembly mode. Now resetting the program. By default, it has the Chrome dyno being preloaded there. I've been demonstrating that before. Well, maybe just to do this one more time. So by default, what you have here in this computer is you are actually having the Chrome dyno game showcasing the capabilities of the computer itself. Yeah, so this is how it works. But we don't quite need this, so let's reset and just get rid of this program. Make sure assembly is available, and we write this to EEPROM as a backup. Okay, now we are going to 0200, so addressing mode, no, the data mode. Now we're going into the data mode, and now we need to put all of these opcodes into the memory. So starting with this one, so 01 LDI and the value of 0, which is okay. Don't get confused by the fact that it prints assembly, even if that's data, not the assembly itself. So then we have 03, so transfer A to B. Then we have calling the subroutines, subroutine and 013C. Then we have calling the subroutine 0126, and then we have subroutine hold on a sec. Yeah, subroutine 0100. Okay, and then rating the character, then loading the program counter to 0200. Okay, so I'm dropping back to make sure that everything kind of does match here. So LDY 00, tab subroutine 01 stop. Oh, is this already a mistake? Yeah, it's already a mistake here. Yeah, I just missed some byte. Okay, 01 3C, and now I need to write everything. 23 01. What is this? Okay, I probably started from scratch. Okay, now we need to put these bytes into the memory. So I'm going to the data mode and say 0100, then 03 to load accumulator to B register, then subroutine 013C, then subroutine 0126. Okay, then subroutine 0100, then read character, and then load program counter to 0200. Okay, makes sense. So drop back to address, and let's check this out. So LDY 00 tab subroutine 0113C, subroutine 0126, subroutine 0100, 07, 08, 02, 00. Yeah, everything is correct. Now let's back up this. So I write this to EEPROM to make sure if I mess up anything that I can drop back, having this sort of a thing. And now let's implement the delay subroutine, because it's the most trivial one. And our delay subroutine is available at the address 0x100. So this is the delay. So all it does is simply waits for 1 second, but since we can't do this in one instruction, we just do this kind of 4 times 250 milliseconds each time. So just say 1f, and fa is the hexadecimal value for the 250 milliseconds. So here just delay, yeah, so this is like fa, so this is like 250 milliseconds, and we just do this 4 times. And then we return from the subroutine. So delay. I could have do this in a loop, but I don't want to because it's just easier to do like this, and then finally return. Yeah, and actually this is the opcode of 24. So now let's put this delay routine into the computer. So we need to go to 0100 and go into the data mode, and we just say 1F FA, 1F FA, 1F FA, 1F FA, and then 24 to return. Let's check this out. 01. So 1F delay, 250 milliseconds delay, third time, fourth time, and then we return. Epic. Now let's back up this to the EEPROM. Okay. So the next thing we're going to be considering, just to make sure that we can actually see something already on the screen. So one of the most essential routines is this one, to print the clock. So print clock is 0126, and let me just find this. Yeah, here it is. And before calling this subroutine, we're going to be considering another one, which like this subroutine would rely on 2 more subroutines. Well, probably let's implement this one first, and then we just add the additional subroutines. So 0x0126, and this is printing the clock. So first we call the subroutine to set the cursor. So 23, 0x01, 0x1b, yes, 1b. So calling the subroutine to set the cursor, to position the cursor here. Okay, then we need to, just wondering, why am I doing this? Okay, then in order to, so we have the instruction to display numbers with trailing, with the leading zeros, and also we need to distinguish whether we're going to be printing the time, outputting the time in decimal or hexadecimal. In order to make this, we need to use the A and B registers, as you can observe this as the function arguments, although those are not really function arguments, but just like you know, like the parameters to the instruction num, which we're going to be considering. So we need to make sure that the A register would be equal to 2, as well as the B register, and this ensures that so B register equals to 2 ensures that we have like 2 digits, like 1 leading 0, and A register to 2 is not equal to 0, which would ensure that we're going to be printing numbers in decimal. So you don't, like 0, A register equals to 0 means that you can print the hexadecimal numbers. Otherwise, if it's not 0, you're going to be printing the decimal numbers. So let's go for it. So I just say 0x01, 0x02, LDI the value of 2, and then tab, so transferring this to the B register. And yeah, then we print our hours. So the x25 is instruction for num. And now we're coming to the variables. So hours would be at address 0000. So just to give an idea here, so hours is going to be 0000. Minutes is going to be 0001. And seconds are going to be 0002. So these are our variables, just to give an idea. Okay, so here we are displaying the number in decimal with like one leading 0 at 0000, which is actually hour. So we are displaying hour here. Hopefully that makes sense. Then we need to print a colon, and we'll write another function for that. But for now, we can just call the subroutine that says 01 22. So subroutine print colon. Okay, and then we just want to print our minutes, and then again this subroutine to print the colon, and then want to output our seconds, and then we no longer need to print the colon, and by this time we just return obviously 24, yes, and return here. So we'll now take this piece, it would be helping us. So we have two more subroutines to implement, so the set cursor and the subroutine print colon. So let's start with the set cursor. So this is 01 1B. So this is set cursor, and yeah, so 01 LDI, the value of 1. So, and then we are transferring this to the B register. So this is how we can set up. So B register is responsible for the row. So row 0, row 1. So this is going to be row 2, row 1, or like this, the second row literally. Okay. And then the column, so 0x01, 0x04, so 0, 1, 2, 3, 4. So here it should be printing, like put the cursor here to type time, to print time from here. So 2, like hours, colon, minutes, colon, seconds. So that's the layout. So here we just LDI 04, and to call the pause, that's upcode 1E, pause to position the cursor, also overrides the display, resets things, and clears the screen. So this pause instructions is quite powerful. And then we need to say return. So like this. So this is the first one, and also another one is this subroutine to print the colon at 0122. 0x0122 print colon. Okay, and 013A, and 3A is the ASCII value of the colon. So this is like LDI and the colon like this. and then to output this F, to output to the LCD display where at the current cursor position. So this is the out instruction here, and that's pretty much all about it. Then we just return. And yeah, so now let's put this stuff in. Yeah, so let's go to, yeah, first of all, so where are we now? We just, okay, so just want to make sure that I back up everything to the EEPROM. So 0, 1, 0, 0. So we have our delay function. And sometimes resistors on this analog input don't work properly. And return, yeah, so far so good. So 0126, so I'm gonna check that out. 0126, we don't yet have anything. So yeah, let's actually start with this tiny guy. So starting at 011B. So 011B, and here LDI 01 and tab. Okay, LDI 04 and 1E to pause, and 24 to return. And now let's make sure that we didn't mess up anything. So 011B. So we are having this, so LDI 1B, LDI, the value of 1, don't get fooled by this, it's just a byte, not an instruction. Then tab, okay, then LDI value of 4, then pause and return. Yeah, so far so good. We can back up this to EEPROM. Okay. And now 0122, which actually goes just right after this one, which makes perfect sense. So 01, and we're already gonna be having an option to test this from now on. 013A and 0F to output and 24 to return. So 0122. So LDI 3A, which is the column here, and F, okay, and return. Yeah, so let me put this into like EEPROM. Yeah, now let's test this. So we can go the single step and sort of a thing here, or we can actually run from, no, it just gets this return, which is not really that great. So let's go for a single step. We're not going to be testing return statement for now, but at very least. So if we just go to 011B, or alternatively, let's actually go to 0300. I just want to write some test code to make sure that these kind of two parts are working properly. So I just call the subroutine 0300, and I just call the subroutine 011B, 011B, and then I call the subroutine 230122. So what? Oh, I forgot to call the subroutine. Okay, again, subroutine 011B, subroutine 0122. So subroutine 0, 1, 1b, this one, call this one, and then subroutine 0, 1, 22, and then we drop. So we go to 300s, and if I now did everything properly, it should put the cursor to 0, 1, 0, 1, 2, 3, 4, and here it should print a column. So let's make it clear whether it works or not, and here we go. Okay, something has gone horribly wrong. Oh well, that's because it just it just drops back. So to make sure that we can indeed test this, 22. Then let's just fake some loop here. So reading the character and looping back to 0, 3, 0, 0. Yes. And yeah, now it's run. Yeah, just as expected. So 0, 1 road, 0, 1, 2, 3, 4, and here is the cursor, and we just put this column. So we're calling these functions in a loop now. So far so good. So now we're ready to write this function to actually bring the clock. Okay, so this magical read character non-blocking allows to escape from program when it's in the infinite loop by pressing the F key. And I'm not gonna be like keeping this, so I just want to reset. And yeah, probably I should already have these two in the EEPROM. So let's make sure it's the case. Okay, and I just load from EEPROM, and I go to 0, 1, 1b, and indeed I have. Okay, pause, return, and this one as well. Okay, and return. So far so good. So we have these two functions. Now we go into 0126, which is the next address. Well, pretty expected. So now we're going to be printing the routine to print the entire clock. So the hours followed by the minutes followed by the seconds. Let's go for it. So yeah, we are calling the subroutine 011b, this one, 011b, yeah, subroutine 011b. Then so what did I, yeah, okay, so we need to put 2 into the B register to make sure that we're printing the decimal numbers and we have 1 leading 0. So here I say, yes, 1B, 0, 1, 0, 2, 0, 1, 0, 2, 0, 3, so 2 to accumulator, then put in back to the B register, put into B register, then 25, print the number at 0, 0, 0, 0, then call in the subroutine to print the column, so 0, 1, 22, then num 0, 1, so here we print the minutes, and here again we print the subroutine to print the column 0, 1, 22. Oh, okay, I messed up, okay, let's drop back, 0, 1, 26. So subroutine 0, 1, 1b, so this is correct. Okay, loading the value of 2 to the accumulator, transferring to B, this is okay. Num 0, 0, 0, 0, 23, subroutine 0, 1, 20, oh, this is wrong. 22. Okay, num 0, 0, 0, 0. What heck is this? This should be 23. Subroutine 0, 1, 22. Okay, num 0, 0, 0, 1. Yes, bring the minutes. Subroutine 0, 1, 22. Num 0, 0, 0, 2. And finally return. Okay, so I just check this out one more time to make sure, because it works, because otherwise it's just not going to be working. So 0, 1, 26. Okay, so subroutine 0, 1, 1b. Yes, we are calling this position cursor every time. Then loading 2 into the accumulator, transferring to B register, printing hours, printing subroutine 0, 1, 22, printing colon, this one, then 25, 0, 0, 0, 1, printing minute, okay, 21, 22, printing, yes, the colon again, then 25, 0, 0, 0, 2, print in the seconds, and return. This should be correct. So I just write this to EEPROM to back up things. And now let's go back to our 300s hexadecimal to test there. So I can call this 0, 1, 26 in a loop now. So I just say subroutine 0, 1, 26. Then I want to read the character, and then I want to loop back to 300s. Okay. 0, 3, 0, 0. And after that, if I did everything properly, it should now be printing 0, 0, colon 0, 0, colon 0, 0. So let's have a look if that kind of works. And indeed, guys, so we have our print clock routine being working properly, which is a good news. So let's reset and let's drop back to 0, 1, 26. Oh, I didn't load from the EEPROM, sorry. Reset again. So assembly, go from EEPROM, and 0, 1, 0, 1, 26. Yeah, we got our subroutine thing. Yeah, so far so good. Okay, so now we drop back to our main loop. So we have implemented the delay, so this is done. We have implemented print clock. This is also done. So now the main kind of part, print, like updating the clock itself, like one of the most complicated and the most essential parts, and that actually should be working. So yeah, let's now try to implement these update. So we have 0x013c. So update clock routines as like gets entered with this update seconds. Okay, so 0x02, 0x00, 0x02. So LDA, and we're loading seconds to the accumulator from memory. And then we want to compare these seconds to 3B. Compare 0x3B, which is 59 in decimal. Okay. Then if it is equal indeed, if seconds is indeed equal to 59, then we want to jump to where our routine to update minutes is going to be available. And well, I already know that address, so I'll put it in here. So this is going to be 0148, and I'll now explain how to calculate this address. So it's going to be just right over in here. So jump to, because otherwise if I would be showing how I'm doing this, how I've been doing this manually, just takes ages. Jump to update minutes. Okay, and then we want to increment seconds by 1. So 0x02, increment memory at seconds. So this would make seconds like +1. And then we just return. So, yeah, 24 obviously, and then we just return. So, this byte it has the address of 013C, 3B, 3C, 3D, 3E, 3F, and so on. And the address of the byte after this one is going to be 00148. So I've just calculated this, not even manually. I've been like the way I've been doing this, I just put the FF. Well, probably I can show you this once, guys, even though it takes time. But then when you understand how I'm doing this, I would be just putting the addresses. So let's go to 013C and start inputting our data. So 02, 00, 02, 0B, compare the value of 3B, no, 3B, and then 0C, jump to, and for now I say FF, FF, so I don't know where, I don't know this number yet, don't know this, and 26 increment memory at 0002, and return. So I drop back to 013C. So LDA, yes, 0002, which is seconds. Compare with 3B with, hold on a sec. Yeah, it's the character, but actually the decimal value is like 59. It's not displayed here, but trust me. Then jump to FFFF, then increment memory at seconds, then return, and then the next address, you see like this 0148. So here we're going to be writing the following code. So now we know, so this is how we calculate this 0148. So since we already know this 0148, we can just drop back to our FFs. So first FF is going to be 01, second is going to be 48. Hope this makes sense. Okay. See, so loading from the memory, loading to the accumulator the value of seconds at 0x0002. Comparing this with the 59 in decimal. If it matches, then we jump to 0148, which is here, which is update minute. Then increment in second by 1, and then we what? Okay, increment in the second by 1, yeah, and then we return. And then 48, yeah, so here we have the routine called update minutes. So let's go for this one. And the logic is going to be quite pretty similar. So first, we need to reset the seconds here. So I say 0x01, 0x00. So I'm loading 0 to the accumulator, and then I say 0x06, which is STA, to store at address at 0x00, 0x02. Store the value of the accumulator, which is equal to 0, to the location where our seconds has been stored. So hopefully this makes sense. Okay. Now we need to do this sort of thing, but now we need to load minutes. So 0x02, 0x00, 0x01. So we're loading minutes. So LDA from the memory, we are loading minutes. And then again, we want to compare those with, excuse me, 0x, 0b, 0b to compare with 59. So compare with 3b, 59 in decimal. Okay. Then what? If it matches, then we want to jump to the address of updating the hour. So since I've already calculated this address exactly the same way I've just demonstrated, I will just use the address. So the address is 0159, 0x01, 0x59. So jump to update hour, and then we want to 26 increment, otherwise we want to increment our minutes. Yes, 0x00, 0x01. So increment memory, we want to increment our minutes, and then we return. Then we return from here. Okay, so now 0x0159, you will now see that this is the address in particular. There's going to be update hour, but first let's put this stuff in. Yeah, and before that, yeah, I didn't yet actually, or no, it's okay. Yeah, so let me just store this stuff into the EEPROM to back up things. Okay, and let's put these bytes in. So 01 LDI 00, so resetting the A register, then 06, store this to 0002, so we just reset the seconds. Okay, then 02 loading 0001, we're loading minutes. Then we comparing the minutes with the value of 3b, and if it doesn't match, then we jump to 0159, 59, then we increment the memory at 0009, and then we return, and you see like this 0159 exactly, we found ourselves exactly where we had to. Anyways, let's make sure everything is done properly, for otherwise just can end up with a complete disaster. So loading the value of 0 into the accumulator, good. Then storing this to seconds, good. Then LDA minutes, okay. Comparing with 59, good. Then if it doesn't match, jump to 0159, then increment memory at minutes 0001, then go into 24, okay. So like then 24 return, and now update hour at here. Okay, so let's back up things. And here we go. So now update our, so first we need to reset the minutes. So like this. So LDY instant immediate data of 0 to the accumulator. Then set this value to minutes. So STA to minutes, right? Yes. Then load the hour, so 0x02, 0x00, 0x00. From memory, we're loading hours. Okay. And now we need to compare it, 0b, with the value of 23, which is 17 in hex. So compare with 17, and this is 23 in decimal. I'm sorry, 17 in hex, 23 in decimal. And I'm already running out of my paper, so let me just, I don't have that much, kind of enough space here, so let's probably do it like this. All right. So comparing, yeah, it's so slow that I need to update. Like my laptop just goes to sleep for some reason. Okay. So otherwise, if it doesn't match, we want to jump to update our, like to reset the hour kind of label. So C and the address is 016A. Otherwise, we just want to jump to reset hour, RST, reset hour. And if we don't want that, in this case, we just increment hour by 1, 0x00, 0x00, incrementing hour by 1, yes. Increment memory, and where the hour is available. So yes, incrementing the hour. Increment memory and the hour. And then we just return. And here we'll have the very last one, which is 016A. So this should be, and here we reset the hour. But first, let's put this kind of stuff in. Make sure everything works nicely. So 0159, and here we go. So 0100, 06 set to 0001. Okay. Then 0 to LDA from 0000. Then compare with 17, which is 23 in decimal. If it matches, then jump to 016A, then increment memory at 0000, and then return 24, and 016A, which is exactly the address. So far so good. So let's check this out. So go to 0159. So loading 0 to accumulator, setting this to 0001. Okay, resetting the minutes, loading hours 00 to accumulator, comparing this with the value of 23 in decimal, and if it matches, we're jumping to 016A. Otherwise, we increment hours by 1 and then return epic. And the final thing here, yeah, so just to make sure that we didn't mess up with anything, so just RAM to EEPROM. Okay. Yeah. So updating hour is quite trivial, so we just say, just reset the A register, so LDI, the value of 0, and then just put this to hours. So STA to the hour, so we reset this way, and then we just return. Yeah, quite trivial. So 0, 1, and then we go 0, 0, then we go 0, 6, and then we go 0, 0, 0, 0, and return. So checking out 0, 1, 6, A. So loading 0 to accumulator, setting 0, 0, 0, 0, which is the hour, and hopefully return. And let's back up things. Okay guys, so we are almost there. So let's drop back to our main loop sort of a thing. So yeah, this is our main loop. So I think that we're already almost there. So not quite sure it's gonna be working just right at the moment, but let's have a look. So I already forgot what we have in our main loop. So going to let's reset things to make sure that I just load everything from EEPROM back. And loading things like assembly, loading things from EEPROM. And I go to 0 to 0, 0. Yes, just to make sure that's, for instance, like 0, 1, 6A. Yeah, I still have things there. So just to make sure that I didn't erase the program. Okay, so it seems like we already have this our kind of main loop. So just to check this one more time. So resetting, okay. And calling the subroutine to update, so 013C. So calling the subroutine we've just considered, then calling the subroutine to print the clock 0126, then calling the delay subroutine 0100, then reading the character, yes, and then 08 LPC, yes, to 0200. Yeah, so starting from now, it should start like printing the time from 0000 and going on there. So yeah, let's run our program. The moment of truth has just come. So hold my breath, and here we go. Okay, so we have our seconds being updated. So, well, here we'll wait 1 minute until it goes to 59, and then to check exactly the same thing with minutes and the hours. Would be manually we're going to be manually altering the values of the variables directly in the memory, the addresses of 0000 hours, 0001 minutes, and 0002 seconds, to make sure that we can test our functionality to make sure the jump logic works properly. So we're gonna be jumping when the minutes are going to 59, and then like the next iteration, it should be 00 here, and increment hour by 1. Okay guys, so the moment of truth, yeah, let's make sure, let's hope this is gonna be working. So 56, 57, 58, 59, and yes, 1 minute. So far so good. So I have to drop back. Yeah, we need to hold this a little bit. Okay, very nice. I'm pretty satisfied. So now let's go to 0000, and so here hours, 1 minute. You see this 1 minute here, and 5 seconds. So that's where we've dropped. So here, if we just set the value to, let's say not, well, actually, yeah, 3B indeed. Because we are comparing, so let me just quickly find this. Yes, update minutes. So we are comparing with the 3B right over in here. So the value should be 3b. Yeah, the value should be 3b. And I just say 3 and b. And then I go back to 0 to 0, 0, and we just run it. So now we have 59 minutes, and once it gets to, well, actually, just I don't want to be waiting that much, so let's go to 0, 0, 0, 0. So let's set the seconds manually to cheat a little bit, like 3, 3, 9, for instance. 0, 2, no, 0, 2, 0, 0. And here we go. Yeah. And bam, we have our being updated. So the very last thing to consider is actually to make sure that we have like 23 hours, 59 seconds, 59 minutes, 59 seconds, and go from there. So 0, 0, 0, 0. So 1, but here we want 17, which is 23 in decimal. 17. Here we want 3, let's say 3, 9. No, here actually want 3b indeed. And here somewhere around 3, 9. And 0, 2, 0, 0. And the moment of truth. Let's have a look. Okay, and bam, we got our clock being resetted just like a charm. Works like a charm. Everything goes well, and yeah, we have this clock. So if you want to set the proper time, like the current time, for instance, so now it's 13:24, and by the time I would be setting this, yeah, so just let me have the calculator to quickly check, to quickly turn this from decimal to hexadecimal. So decimal 13 to hexadecimal. So this should be 13 is 0D, and 25 minutes. Let's take 27 because it takes time. It takes time. So say decimal 27 and hex 1b. So 27 is 1b. So the current time here is 13:27, which is 0D1b. So let's set this time. Okay. All right. 0x 0000. So we have 0D and 1B and 0, 2, 0, 0 and go. And yeah, we got the time, guys. So I'll now bring my smartphone to give an idea that this is actually the time. Yeah, and let's have a look. What kind of time we got here? Yeah, we got this kind of exact time like we have on a smartphone. Yeah, probably our clock is a little bit fast, going a little bit faster, but yeah, just already 28. Here it's still 27. But I hope you get the idea, guys. So yeah, this is kind of pretty much it in regards to this video. We've just implemented digital clock in machine codes on the CMK computer, and yeah, hopefully you're now seeing this exact time like running on your emulated version of this computer in a web browser. This is it from my side. Thanks for watching. Until next time, and take care.